Hello and welcome everyone. Thanks for making the time today. I'm Brona Nielsen from the GenAI Black Belt team here in EMEA Technical Engineering. If you've ever opened a spreadsheet with 20 tabs, merged cells everywhere, cryptic headers, footnotes that don't line up, you know the pain. And that's really what today is about: messy, high-value documents. The kind of files that makes humans groan and make AI stumble. So this session is called Agentic RAG for Complex Documents, but this won't just be theory. I'm going to show you an end-to-end pipeline on OCI and why this approach makes a real difference when traditional RAG falls apart. Since I'll be showing you this pipeline running on OCI, first of all, the safe harbor statement. Since I'll be running this on OCI, I'll give you a 30-second version of why OCI actually matters for AI. At the infrastructure layer there at the bottom, you have AI optimized clusters. So these are GPUs wired together in our supercluster architecture. That's what gives you the horsepower for training and inference at scale. At the data layer, then you have machine learning models right inside the products, like Autonomous Database and MySQL HeatWave with AutoML. So you don't have to be a machine learning expert to put models next to your data. At the developer layer, then we have services like GenAI and agents and digital assistant. So you can call the LLMs or you can add natural language interfaces without having to build your whole stack. And of course, across the application layer at the top, Oracle apps, they embed domain-specific AI for finance, healthcare, retail, public sector, and more. So that's what customers are running today in production. So when I show you this demo, it's not just a toy pipeline, it's running on the same infrastructure, database, and services that are production ready. All right, let's agree on what we mean by complex documents. You know them when you see them, and you usually groan. So here are 3 excerpts from real-world style spreadsheets. Notice the patterns. You've got multi-level headers, merged cells, odd footnotes, semantics baked into the layout, inconsistent formatting, inconsistent units. They're not designed for machines, they're designed for people. And we see this everywhere: finance, legal, healthcare, social, banking, compliance reporting. Take ESG reports as an example. So ESG stands for Environmental Social Governance. These reports are massive, compliance critical, and almost impossible for AI to read directly. And that's the problem we're tackling. So for today's demo, I'm going to use some fake but realistic data from 2 fictitious banks, Elenexa and Ailwin, just banks I made up. You'll see a lot more of them later. So this is exactly the kind of stuff we wish AI could just handle for us. And of course, the natural place where most people start is with RAG, Retrieval Augmented Generation. What is RAG? Here's the basic recipe. You take the user query, embed it as a vector, search the vector store for semantically similar chunks. You send both the query and the chunks to the LLM and get an answer back. Simple, and it does work when your data is clean. Ask it something like, what were Scope 1 emissions in the UK for Elenexa Bank in 2023? And you'll get a clear answer: 9,406 tons of CO2 equivalent. Why? Because the query vector is sharp. It points straight to a neat self-contained row of data. But remember those messy ESG spreadsheets we just saw? That's where things fall apart. So here's the problem. When you throw these messy ESG spreadsheets into vanilla RAG, 3 things happen: structure loss, chunks get split away from their headers. So suddenly 9406 isn't clearly tied to Scope 1, UK, and so on. Context fragmentation. meaning gets scattered across multiple chunks. The model sees fragments, but not the whole row or the section. And entity confusion. So if multiple entities appear in the same chunk, which happens all the time in ESG or finance documents, their embeddings are going to get blurred together. So your query for one might retrieve text from another. Now in my pipeline, you'll see later I avoid this mixing issue by uploading each entity separately and tagging it explicitly. But this is a common failure mode in vanilla RAG setups. And the bigger point remains, your query vector doesn't land on a clean target. It falls into vector soup. Instead of a sharp arrow hitting a bullseye, you've got an arrow landing in the nearest blob of semantic mush. That's when you get the wrong year, the wrong metric, or a hallucination. And it's not the fault of the vector database, it's because embeddings are fuzzy averages of meaning. If your chunk is already messy, the vector can't carry the structure that you need. So how do we fix vector soup? We don't just pour messy chunks straight into the vector database. We rewrite them first. That's the job of this chunk rewriting agent. It runs at ingestion time. So the way it works, for each structured chunk, it asks, is this messy or ambiguous? Will it lose context if I embed it just the way it is? If so, the agent calls the LLM and asks it to rewrite it in clear, natural language. So the before and after is here. The before is on the left, the after is on the right. On the left, you've got raw ESG extract, so merged cells, cryptic numbers, pipe delimiters all over the place, basically unreadable for retrieval. On the right, you have a rewritten chunk. So statements like Elenexa reported scope 1 emissions of 9,400 tons and so on. So everything is explicit, the entity, the year, the scope, the unit. Now, when this gets embedded, it's not soup anymore. It's structured, precise, and retrievable. That's the first step. The next, what about task decomposition? So rewriting, as we've seen, will fix the input on the input part of the pipeline. But what about the query side? Because when a user asks a big, messy question, compare ESG across 2 banks, 3 years, 3 emission scopes, and so on. Embedding that as a vector is just as much soup as the raw spreadsheet was. So everything will collapse into one fuzzy point, no structure, no separation. That's why we need task decomposition. Instead of dumping the whole query into the model, the planner agent will rewrite it into a clear set of subtasks, like you see here. So retrieve scope 1, 2, and 3 for each bank, and so on. And then it will align the results for comparison. So each subtask is precise. Each retrieval has a clear scope. Now the model doesn't have to juggle everything at once. It works step by step. And the result is faster, cheaper, and more reliable reasoning. In other words, no more soup at the query side. Now, some of you may be thinking, wait, can't a sophisticated LLM with tool calling just do this itself? Break down the task, fetch the chunks, write the report? Technically, yes. You can brute force it that way, but here's why we don't rely on that approach. Number one, determinism. A one-pass LLM will behave differently each time. But in a pipeline like this, it's predictable and testable. Cost as well. One giant loop will burn tokens and time. A pipeline is quicker, faster, and smaller with each run. And reliability and accountability. When something goes wrong in an LLM, you want to know whether it was in the planning, retrieval, or synthesis stage. That's only possible if the steps are separated. So yes, one model, a powerful LLM, could do it all in theory, but if you want something that you can run in production day after day with compliance teams watching, the deterministic multi-agent pipeline wins. So here's the full lineup. Notice there are actually two phases where the agents come into play. You've got the ingestion phase, the chunk rewriter agent that we've seen. It runs just once when the documents are onboarded. Its job is to translate those messy inputs into clean, embeddable text. That's the pre-processing. You pay that cost once. Then at the runtime stage, when the query comes in, the planner, the researcher, and the document writer agents, they take over, breaking the task down, fetching the right evidence, assembling the output. That's the live reasoning phase. And conceptually, this split matters. One agent cleans the haystack in advance, and the other three know how to find the needle and stitch it together. Here's that familiar RAG diagram again, but notice the difference. With vanilla RAG, the query goes straight to embedding, to retrieval, and it's a one-shot answer. With agentic RAG, the query will first hit the planner, get the subtasks, and then retrieve tailored information for each step. And then the document writer will put it all together in a structured report. So it's the same bones as RAG, but it's smarter at both ends. That's why it scales to messy, multi-entity, multi-year documents, whereas vanilla RAG just drowns. Enough slides. So let's see this running. So it's all running on OCI. So we're calling the LLMs on the OCI generative AI service and the embedding models as well. And here I have my Gradio front-end app. So this is a Python library, and it's wired up to that pipeline on OCI. We'll walk through it step by step: ingestion, query, and then the full agentic run. You'll see exactly where plain RAG will stumble and how the pipeline will fix it. So let's start with ingestion. We're going to load in some ESG data for Aylwin Bank. And I'm going to give it the entity name. And now it is ingesting the chunks using the chunk rewriter. And we will ingest the Iranexa. So what's happening in the background here, you can see it is ingesting those raw chunks, and it is, so you can see they are very fragmented, full of pipe characters, very disjointed information. And it is rewriting them into natural language sentences using a prompt. Let's have a look at the agents that are running. So this is the chunk rewrite agent, and its task is to take in that messy file and then to transform it into clear natural language. So we're calling the LLM to do this task for each of those chunks. Okay, so we have the Aylwin. Let me just upload the other one. Yeah, it is uploading. And once it goes into the vector store, then we can see how it's been rewritten. So here you have your nice contiguous natural language sentences that give the data the complete context. And this will of course help retrieval. Okay, so we've done with the ingestion of data for both banks. Here we see we have two documents, and now what are we going to do with them? So we'll move over to inference. So let's try a plain vanilla RAG query in action. So we're not going to use the agentic workflow. The vanilla RAG is going to benefit from this chunk rewriting, so it is going to have better chunks than just ingesting an Excel in a naive way would have. But we can contrast still the agentic versus the non-agentic RAG. So let's give it a very simple query. First of all, we're using the Grok model running on OCI. We're using the same embedding model that we used to embed the chunks. It's very important that those embedding models are the same. And in this case, it's the multilingual Cohere model. So now it's doing vanilla RAG. It's doing embedding of the query, then it's searching the vector store, but it's not using the planner or the researcher or the report writer at this stage. This is vanilla RAG. And let's see what the Grok model, which is quite a powerful model, can come up with. And it's searching through a lot of chunks. And here you see the response. So it isn't bad. It has used 16 chunks in total in this search, and it's okay, but it's short on detail. Now let's try a more complex query, the one that is more the type that you would actually have in a real life scenario. So this is a massive prompt. You are an expert, generate a structured report, context and scope, and then break it down into environmental, social, and governance. And we'll see how Grok will manage using vanilla RAG on that. So just to remind you of what that query is, very typical of ESG style reports, where you have to give exact comparisons across two banks. So you're breaking down the E and the S and the G part into 10 to 20 different subtasks. And then you can say things like use headings and make it clear, make it report-like. And it is working away, so it's retrieving chunks, doing the normal, the RAG comparison, so vector comparison, choosing the best vectors to prompt the model. And it's taking a long time. And this, of course, is the issue when it comes to naive RAG. You've got a massive prompt. It will retrieve a huge number of chunks from the vector store in order to answer the query. And it burns up tokens. So Grok has a large window. So it has a context size of 16,000 on this surface. So it's using up most of that in order to answer this query. It will get there eventually. Okay, so here we have the response, and we have a table that's nice, narrative analysis, social performance, and then some recommendations at the end. So it did manage to pick up quite a lot of information. But it's not extremely detailed. When you look at the original prompt, the prompt is almost as long as this report that you're getting. So it's clear that it hasn't really picked up all the information that you would like it to. Let's contrast that now with the agentic workflow. We'll run exactly the same query. And this time, the planner agent is going to kick in, first of all. And then the researcher agent is going to find the best end chunks for each of the subtasks. And then they pass all of that information to the report writer. So here you can see it's going step by step through each of the subtasks. So here you can see it's doing renewable energy sourcing. It's finding for each of the banks for Elenexa, for Ailwin. And it doesn't have to retrieve so many chunks each time because it's a very targeted query. And the token count for each of these calls is also a lot smaller. And it keeps going through this list. So the researcher agent that kicked in at the very beginning, that will create the plan and everything else will follow from that. So this is the planner agent code here on the top. And there's the prompt that is guiding it. So it's very explicit about how the results should be returned. And we use JSON to allow the agents to communicate with each other in a very structured way. And LLMs have a tendency to break down JSON or not stick to the rules when it comes to JSON. So you have to be very explicit in your prompt about creating a clean JSON result every time. And that's how these agents can talk to each other. And of course, when it comes to comparison, then you have to explicitly tell it, okay, if it is a comparison, make sure you're selecting data from both of the entities that you're comparing. Then the report writer agent, it gets the information from each section, and using Python libraries, then it will create graphs and create tables. So this is to give it the nice polished professional structure at the end. So we have our report. There's the query again, and let's open it and see how it looks. We have an executive summary, environmental performance. We have color-coded graphs because that the section writer agent was instructed to use different colors, so it'll be really clear which bank is which. Then the social performance. And important here that it's never going to make up data. If it doesn't find data for one particular bank, it's going to say NA. It's never going to hallucinate. So these are the kind of ESG reports that banks and other institutions have to compile all the time. And then the governance section. And again, you can see it's really gone into detail. It's covered every single topic that the original query asked for, which is in direct contrast with what the basic LLM call did. And then at the very end, you have your conclusion. So you get an overview as to which bank is performing better. Again, very useful to people who are working in this industry and need to, have an executive overview of how their bank is performing with respect to another bank in terms of ESG compliance. So that's the full flow. You ingest messy data once, you rewrite it, make it clean at query time, let the agents plan, retrieve, and generate step by step. And the result is this kind of structured, reliable answer, running end to end on OCI. So messy data, it isn't going away. Complex documents like ESG reports, they're mission critical for compliance and legal. Traditional RAG will struggle. It loses structure, it misses context, it's blind towards entities. But with chunk rewriting and agentic RAG, we fix those gaps. So you get answers that are clearer, richer, more accurate, and auditable. And why build this on OCI? Because everything you just saw is built on secure managed infrastructure, one that customers are already using in production. So these are enterprise grade LLMs and embedding models, and they're available right here on the console. You have secure APIs, governance, multilingual embeddings, fine-tuning options. It's not just a toy pipeline, it's running end to end on infrastructure that's in production today. And for you guys, this isn't theory. You can take what I showed today and start experimenting. So the demo code is on our GitHub. So go hands-on. Try it with your own messy data and see how far you can push it. And if you're working on a similar problem, just reach out. We're helping customers solve this kind of challenge every day. So yes, go build with this today. And remember, this isn't future tense. This is reliable, secure, and it's here now. So thank you for your time today. I hope this session gave you inspiration and a concrete path forward. Let's keep building. And now back to Violetta.
Thank you, Brona. Very nice demo. And we had a lot of comments on chat. Our customers enjoyed it, so thank you for that. There is a question that is a very good one, and I would like to answer, to read it to you, and maybe we can provide an answer now. I believe you kind of mentioned that, but let's do it again for everyone in the call. So there is somebody asking if we can ingest other file type as docs, PDFs, or extract some specific details from them to use in other processes. Is this possible, Brona?
Oh, absolutely. So this particular RAG setup will also ingest PDFs. But the reason that I focused on Excel sheets was because we had so many problems ingesting Excel sheets. Those were the absolute hardest documents to pull data from in any kind of correct and accurate manner. The PDFs had various libraries that could be used that made chunking pretty good, but Excel sheets were an absolute disaster. There was no way to ingest that data using the libraries that we could find. So hence this whole rewriting structure for the Excel sheets. But of course, you can use any kind of documents, PDF, text. You can even ingest images. So we have image embedding models on OCI. So you can ingest images as well and embed those same as you would for text. Everything is possible.
Thank you, team, for answering them all. Thank you, Brona, for the great presentation and demo today. Thank you, Iliada, for assisting us in answering all the questions on Q&A. If you have any further questions, feel free to join us on the Slack channel, Developer Coaching Events, and raise the questions there, or you may as well use the email that you see now on the screen if you need further help from our team. With that, I would like to thank you all once again for joining us. Enjoy the rest of the afternoon, and we hope to see you in the next ones. Bye-bye.